Welcome back to our Python class, and today we will explore one of the biggest and most important Python libraries for data analysis. I would say the most important library for data analysis called Pandas. You might have heard of it, right? It is used for pretty much anything which involves some sort of data manipulation, transformations. So basically, in other words, you can say it's an Excel on steroids. So it's a way of manipulating tabular data, not only, but it works on much bigger data sets, even millions and even billions of rows if you need to do it. So it has a huge ecosystem. You can see how many big supporters. There is the wife of Mark Zuckerberg, for example, NVIDIA, big supporters. It was started by a data analyst in New York, in Wall Street, Wes McKinney. There's an official book for it. Here, it's pretty good. The new version is actually pretty good. Old version is fine as well. Right, so, and also has very good documentation. Again, it's a huge library. We could spend a couple months. Maybe we'll do some more work on it, and we will encounter it again and again. We saw it previously when we were reading JSON, but it does work with pretty much any type of data. But overall, the basic idea is you work with something called data frame. It's a concept from, actually comes from some other languages, but again, basically very familiar, I think, to most of us. We have rows and columns, and we want to do some work, right? So again, you have some data, you want to do some analysis on it. Right, so let's get started. And I will be using as a base for the following introduction, I'll be using a notebook recommended actually by Pandas. Right, it's by Stephanie Molin. She's actually author of Hands-on Data Analysis Pandas. Apparently she works at Bloomberg, big financial company. And here's her LinkedIn, right? And so pretty nice stuff here, right? And you can see here other notebooks, but we'll be using some of the introductory ones. Right, so again, so we'll start with using data frames, but let's get started first, right? So again, basic building blocks are series, right? Series, you can think of them as a column basically with an index, right? Data frame, which is basically what I just showed you here, right? And that's the most important concept actually in this whole library. And then we'll also see index classes, right? So basically, anatomy of a data frame is actually series, right? We won't use series by themselves that much, but we will use a lot of data frames. So it's very typical to import pandas as PD. Again, a reminder that this is the official website is here. So again, it's a tool. Pandas is a tool for working with various data sets, for cleaning, exploring, manipulating data. Also includes visualization tools, data munging tools, so to say, right? We can make some, we can clean some messy data sets, right? So a lot of work, right? It's a very versatile tool. Of course, quite complex, but I think you will get the basic idea pretty quickly, right? So we import as pandas. We did this actually previously, right? And then once we import it, I will move it up. Right? Escape A here. Let's see. Right, we need to import it, right? We need to install. Okay, if you don't have, by the way, if you don't have it in your, you should have your virtual environment already running, right? And so usually you install it here, right? Of course, you import it here, right? Again, if it's not imported, so what do? Well, you get started, right? Getting started. Installations pip install pandas, right? Again, there's some other ways of installing, but pip install pandas will get you, right? So let's get the version. So what's our current version? Double check. PD version. Let's check. It should be or I can't type, of course, that's why I get nothing, right? So yeah, 1.0, 1.50, anything 1.3 and on, or actually anything over 1 will work just fine for most of these things we do. So again, so this is our big module. So if you check here, right, PD dot, right, you'll see that it has a lot of functionality, right? Look at all the good stuff there. Read. So for example, read CSV is not the only thing we want to do. So we start by reading some CSV data into a Pandas data frame. That's our start, right? And It's going to be something from NASA, I believe, right? We have also, you notice there's data folder, which is a sibling to all these folders. So what does it mean? So we use to go back one directory, right? Then we use to into the data directory. So yeah, so these two dots means we back up, right? Very common, right? This is the instruction for backing up, right? And also, number of rows. Well, actually, this is very tiny. So number of rows parameter. It's maybe a little bit rare, right? So n rows, right, means we only want to read the first 5 rows of the CSV file. I would say it's not very common. Usually you want to read everything. So this would be actually something, this is one way of doing it, right? Right. However, usually, right? Okay, I'll make a new one. Usually we would read the whole file, right? So this would be actually something like this: df equals, right, and I would do df head. So it's also very typical, right? Very typical to call data from df, right? That's very typical, right? Again, of course, you can naming is very nice, but df is very common if it's just something generic. So here by default we get the same thing. Here we get the first 5 rows of the data frame by default, right? We can adjust it, right? If you want more, right, we can also get the last 5, right? We can get, let's say, df tail 7, you know, get last, you know, get the last, right? So okay, Zhong, Zilla, Zinder, Zlin, Zhukowski, and Zulu Queen. All right, these are all the meteorites, right? So you can see, of course, from the index, looks like 45,000 entries, right? Pretty good, right? So, but we can get also the shape. We can also get some basic information, such as shape, right? Such as shape, right? Right. Basic. We can get some basic stats, right? Some basic stats. We get the shape of that frame, right? And also very important might be get information about data frame would be df info, right? This tells you what kind of columns and what kind of data are stored there. Again, reading with CS, and also to notice it shows you how much memory it's taking. Only 4 megabytes, right? Because you have 45,000 rows, but pretty good. Also, notice something interesting here. You can tell some things even here, non-null. So 4576 entries, so these are matches, but some of these columns actually are missing information. So some of these meteorites, we don't really know the information about it, right? It's also something to keep in mind, right, later on, right? So this is some basic information, right? So yeah, we'll get back to it. We'll also get to describe, but for now we can also so this using this syntax alternative way to column would be the meteorite's name, right? So right, this is using dot notation because, yeah, I would like to, with all due respect to Stephanie, there's a little bit of controversy. I like controversy about using this dot notation. If you can think of it, dot notation, dot notation for column access will not work if the column name has space in it. Also not work if the column is a Python keyword, right? You know, for example, you know, class or string or def, etc., right? Yeah. So, you know, so, or if, right? So if you name if you have a name of a column class, probably you don't call it if, but class, you know, is could happen, right? So that's why then you have to use the notation, right? Which is of course less more, right? More work, right? Also notation is to be used when we use variable to access columns, right? So yeah, so this is very convenient, right? Unfortunately, like I said, it doesn't always work, right? Because sometimes you have columns which have some conflicts. So that's why some data analysis says, okay, don't use this notation, but it's just too convenient, right? So I try to be pragmatic. I used quite a bit because it saves time, because of course you have to type in this full name, right? It's not that great, right? So again, so name, right? Let's say I want to get a year, right? I could do this, right? I could do meteorites, get year, series will be yeah, year would be on, I would do year. So this is a series, right? Oh, and this is actually from DF. I mean, well, again, it's 45,000, so I'll do now I see why she wanted to do only 5, because again we'll run into space limitations, only have 5, right? So again, so this is series, so this is series, right? So this is, so type year, this is Pandas series, right? Technically, for those who want, actually it's basically underneath Pandas series is a NumPy array. It's a special, it is, think of it as a list which is very efficient, right? So-called well, right, it supports vectorized operations. Underneath, it's also stores data homogeneously, right, in one big block of memory, unlike all the same type, unlike Python lists, right? So this is takes about 8 less time space than Python lists. Again, so it's very good, but again, the downside of this is, of course, so the support fast operator, and of course, you know, fast indexing, etc., etc., etc. And again, you see, but downside, yeah, well, no, you can change it. Is that data has to be homogeneous, same data type, right? So yeah, so that's a series. So that's actually underneath, under the engine. Maybe I don't think we'll have time to go in under the engine in this course, but maybe we'll do it in the next course for those who stick out. But so yeah, so it's very efficient, right? So it's about as if you can't really get more efficient. Basically, it's just basically raw memory with some benefits, basically, right? So now we have this series, right? Like I said, we saw it here, right? Where is it here, right? So so it's basically a bunch of series like this, and they have, of course, they have index again, but typically we'll have again, so each column will basically be a series, right? So let's check our columns, right? Very useful. We can have our column names, right? So that's our so pandas columns are series. Well, yeah, columns are series, basically, right? And well, right, so yeah, data frames are collection of series, technically, right? Yeah, so with the same index. Yeah, thank you, AI. And I guess that's enough, right? So maybe I'll give you a link to this page. Maybe I will give you this link, copy image address, and let's make a nice little where's my escape M? Come on, no, control escape Y. Okay, I want to make a new column, escape B, right? So this one here, escape M, right? On this will be, remember, or image, right? Data frame, right? And let's try it. Yeah, thank you. Hopefully it'll work. Yeah, it works, except it's not very pretty, right? Not very readable, but okay, yeah. Not very readable. Maybe I should have made it because it's an SVG file, actually. Right, okay. Now, right, so let's see what we can read, what kind of data we can read, right? So again, what's this here, right? So this is escape Y. Okay, and change this to, I'm gonna change to change cell to code. Okay, yeah. So columns are series, right? And they have the same index. Okay, so columns, we can get the name of all the columns, right? And we can also get index. So pandas index, right? So pandas index yeah, so yeah, index is, well, series special, well, of the special series, right? Well, special, it's basically special data type, basically, right? It's not really, well, you can say there's series underneath, but it's really, well, it's, series has their own index, right? So it's special data type, right? Index, right? Range index. Here it is numeric. Indexes, pandas indexes can be, yeah, used to access rows, of course, and they can indexes can be integers or strings or dates, right? So okay, right. So we read it. We just read the CSV file from a data directory, but one of the strengths of Python, the pandas, is that we can read pretty much a very wide variety of data source. If you go to this page, if this link here, right, this link here, it will be show you what you can read. You can read CSV, which we're using. There's also a writer. There's read from fixed with text files. If you're using some ancient files which are just fixed with, that will be something from maybe 60s or 70s. There's JSON, which we just saw in our previous. There's even read HTML, which we'll explore more in depth next week when we work with web scraping. There's latex, XML, right? Clippy, clipboard, right? Excel, of course. There is a little, we'll talk about Excel. There might be a need to Excel to install additional libraries. Some of these, like such as Parquet, which is very compressed data format, and a Feather, they might require some extra additional imports, right? Well, not imports, but a library installation. And there's of course SQL. There's even Google BigQuery, right? And Stata, SAS, and SPS, which are the big statistics packages also used by corporations. And maybe some of you have even used them before, right? So support is pretty pretty good. And of course, there's also even more adapters for some other databases as well, right? So read CSV. Yeah, if you go to documentation, again, usually you will look at this, right? CSV is probably one of the most difficult methods you will encounter. Again, read CSV as a method. Look at all these default parameters, right? Because why? Because CSV is extremely complex, because nobody has any standards for CSV. You could have a separator comma, you could have a what kind of quotes you use, what kind of encoding, what kind of, do you want to skip headers, do you want to skip some rows, you maybe want to ignore some values, and so on, right? So because there's no standard, so that's, but Pandas tries to make you some the same defaults, and you can adjust it as needed, right, depending on your CSV file, right? So in this case, if you check our file here, right, it's pretty standard, right? A comma, right? Only thing also is using quotes for escaping some double values, right? And again, that's standard, so this will be read quite nice. Notice sometimes you see some missing values. There's some commas. Yeah, you have to see some two commas in a row, right? Maybe if you find it, right? Let's see, let me see if I can find it. Yeah, you see here, there's missing value here, right? And of course, CSV, Pandas will pick up on this, right? So, right. So, and of course, first column is by convention is usually the column names, right? Again, I'm sure you have used something very similar before. Okay, so let's continue. So we can, again, I don't need to import, we already read it, right? So we can also request, we just saw it, right? We can use requests, right? Previously, right? Let's see if this still works, right? This is from NASA, right? Resource to using requests library, right? Which we already know, right? And of course, by now you will be able to, respond to JSON, right? This is just JSON. Remember, we did this before. So let's see if this works. Again, typically, we would have the import at the top of the file, but again, right? So again, so you don't have to import every time, but let's try it. Did it work? 50,000. So we put parameters, right? This is, in this case, you see the parameters because we want maybe only 50,000 entries, right? And looks like it worked, right? It was success. I would say success, print success. Yes, success. Yay. So very good, right? All right. So I'm not going to do it again, but I'm sure it will be. So again, we don't need to import again because we are already running this payload. So let's see again, and this will be exactly the same, right? Again, I'm overwriting the old one. I overwrote the old one. I overwrote the old df, right? Right. So old one will be garbage collected automatically, right? You know, within seconds. So you don't have to worry, right? So this means you do not need to do it. Yeah, so that's very good, right? So I'm overall, because again there's no reference to so old. Of course, in this case it's very similar, right? So again, so you can save to Excel or CSV, right? So very typical, you know, just simplest thing would be maybe you read it from this JSON. You want to save not only to CSV, right, which would work, right? But I could maybe save it to Excel. Do we have any Excel files here? Let's take a look at our data portal. Do we have any Excel files? Let's try it. So I want to show you this before we finish this exciting recording. We'll see if this works because we might need to install additional library, right? So let's see, right, before we continue inspecting. So if you want to save to Excel, right, to save to Excel, right, and of course NASA meteorites, but of course again it will save in my Day17, right? But I want to save in data, so what I do is, of course, I go back, data, and NASA meteorites. I don't have it, right? So something like this, right? Let's see what happens, right? This might require this saving to Excel might require you to install. Yes, indeed, that's what right? So yep, thank you. My AI assistant is fantastic, right? That's what I want to warn you about. It will tell you, will it work? Yeah, module not found error. So why? Because no module found. Oh, so this is for some reason package manager is does not installed by default. So what do? We are in our virtual environment. What I'll do is I will do pip install open PyExcel. This is for installing on the for working with Excel files. So pip freeze requirements to check freeze requirements, right? Okay, and just so we keep track of what we have or what we don't have. And now, of course, I will want to run the top cell, right? Where's my pandas? I will run this. That's why, right? I need to import it, you know, because I need to restart it. But no, of course I could restart the whole thing, but I just want to re-import pandas, and now I should be able to. Again, where's my JSON payload? My payload, right? Where's my payload? Again, payload is probably. Let's try this saving it. And we have our data NASA meteorites. Hopefully saved. It's taking. It's of course Excel is not good for working with such large data sets. As you probably have found out, if you have 100,000 rows in Excel, it might take a while to, yeah, so, okay, so Excel is not, yeah, not for, also not good for working with large, right, so, over a million rows for sure, right, maybe even less, Right. Okay, so that's what we have done. We have opened up, we read some files, we read some data frames, we read data into data frames, we saw some columns, we have some index, and in the next lesson we will start working with individual rows and columns, getting some more information, and also just to show you our payload, right? Payload, again, reminder, payload was, of course, type payload was was probably list, right? Yeah, it's a list, you know, so probably list of, we can check our payload was probably first 5, right? Yeah, you see, very similar to what we did in our previous exercise, right? So only again, it is the same problem that the latitude and longitude are under geolocation and it's not completely flat, right? So yeah, so we have saved the data and we can proceed to manipulate in the next part of the lesson. So to continue with inspection.